And that's what the internals look like. There's been a few modifications done to this one. While it needs everything to fire, the most important part of this assembly is the plunger, tube, and breech of this thing. Here, this tube, and the spring. Okay, so we have those three parts out of the gun. Yeah, I guess it's three. With the bolt sled still attached. That's what the breech kind of rides back and forth across. Compression is caused by the larger tube being forced down over the smaller tube. Smaller tube has a much smaller inside diameter, so that's where the air compression is caused. It all works together by the breech being moved back and then pulled forward and leaving that tube behind, and then the spring is compressed over. Here's a demonstration of how the whole thing works together. This is the gun we're actually using to test fire because the other one had some problems with. It's a change I wouldn't like to make, but there's a few types of potential and kinetic energy going on. The first example of it is in the magazine, the thing I'm pointing at right there. It's got a spring in the bottom of it that pushes the darts up. So when the darts are at the top, there's only potential energy, but as soon as the dart's removed, it's turned into kinetic energy. See? Another one's pushed up into place. It's moved that much. The spring is compressed by the person pulling it back, and then the breech is closed by pushing it forward. What you have is a buildup of kinetic potential energy somewhere about here with the compressed spring, and when you pull the trigger, the spring expands, the volume of the air container contracts, and the little dart goes out the barrel.